Hello, welcome to a tutorial on how to use the probability calculator from GeoGebra, which is a mathematics software accessible online. In this video, we're going to use this probability calculator to compute some more probabilities in context. If you don't know how to access this probability calculator, watch my video about finding probabilities with the normal distribution. All right, let's look at an example. This is the continuation of a previous video. Suppose scores on a particular standardized test were normally distributed with a mean of 462 points and a standard deviation of 119 points. First, it's important to note that we're told that the scores are normally distributed, so it is good that I'm using my normal distribution. It's good to double check that indeed I have normal selected. Let's look at the question. A graduate school requires that its applicants score at the 90th percentile or higher on this exam. What's the minimum number of points a person could earn to be considered for the school? So note that in this question, it's not asking a probability. It's not saying what's the probability that a randomly selected student scores higher than 20 or something like that. Instead, it's telling us a percentile and it's asking about the number of points. In terms of our formulas, we know our mean and our standard deviation. What this question is asking for is it's asking for an X. It's asking for an actual observation. So whenever we start these questions, the first step is still to try and sketch my situation. So I'm going to draw my normal distribution. I'm going to draw my mean, which will happen at the peak of the normal distribution. That's 462. We can sketch in the standard deviation, but I'm happy with just having a general idea of what's going on. We're interested in particular looking at the 90th percentile. So as a reminder, 90th percentile, that means that 90% of test scores fall below this point. That is the definition of a percentile. It means 90% of, or whatever percentile you have, that percent fall below that given value. So scoring at the 90th percentile means that I want to know what score does someone need to have so that the probability that someone falls below that score is 90%. In pictures, we're saying that below, the reason why I'm shading something below is because it is a percentile. That is kind of the definition of percentile. It's falling below. And I want to know, what does this score right here need to be? What point on the distribution, what on the x-axis of the distribution do I need to be at so that the shaded area underneath it is 90%? What does this need to be so that this area is 90%? So to figure this out, we're going to start by using our probability distribution. I'm saying, okay, I know that I need the area to be 90%. I'm interested in a less than situation because I'm looking at a percentile. So I'm going to select less than. I know what my probability is going to be. I know what the proportion is. So I'm going to highlight the box on the outside of the equal sign, the probability box, type in 90, and I see, okay, what I've just found here, reading this other value, is it's telling me if my z-score was 1.2815, then the probability that that z-score, or that any particular z-score falls below 1.2815 is 90%. It's saying, all right, the z-score that I need for this point right here should be 1.2815. So to find my value, I know that the z-score is equal to the data value minus the mean divided by the standard deviation. This is how we compute z-scores. And I know what some of these values are. I know what the mean is because I'm told what the mean is. The mean is 462 points. So I should be subtracting off of 462. I also know that the standard deviation is 119 points. Again, I am told this. So I know what the standard deviation is. I know that should be 119. And so the thing that's missing here is I don't know what my observation is. That's what this question is. I'm asking ultimately, what does this x need to be so that when I do this calculation, my z-score turns out to be 1.2815, which will ensure that the area below this point is 90%. So I'm just going to put an x here for the moment. I don't know what that value should be yet, so I'm just going to put an x here. But I do know what z is supposed to be because I was told that. I know that z should be 2.1415. So, sorry, 1.2815. So I'm going to write that down right there. 1.2815. I know this must be true. And if I have this, then I can solve this equation for x. So to start to solving this equation for x, I should begin by multiplying both sides by 119 to get rid of the fraction. So multiplying both sides by 119 gives me, on the right side, I am calculating 1.2815 times 119. That ends up giving me 152.50445. I probably don't need all of these decimal things, but it's all right. Still got x minus 462. And then to solve for x, I need to add 462 to both sides. So adding 462 to both sides, being careful to keep place values in correct order. Adding those things together, I end up with a little bit of rounding, about 614.5 and a little bit more. That should be equal to x, and so this is my answer. This is telling me, all right, if I had 614 as my score, the area underneath that score is going to be 0.90. It's going to be 90%. The value that I needed to find to make the z-score be 1.28 is 614. So what this is saying ultimately is a person must earn, in this case, about 614 points or higher to be considered. Because a person must earn 614 points or higher to fall in this category to be in the 90th percentile. Let's look at one more example. Another graduate school expects its applicants to be in the top 1%. Again, what's the minimum number of points required to get into this school? Note again, this question here is not asking a probability. It's asking about points. And the variable that we are measuring here, this variable is normally distributed across, in this case, points on this exam. So this is another inverse situation where I am being told a probability, I'm being told a proportion, and I want to find a value. So I'm going to start, as always, by sketching. That's a good start always. So I will mark my mean just to help me visualize things a little bit, 462. And again, my question here is, all right, what is the value? What minimum number of points do I need to achieve so that I'm in the top 1%? That means, because it says top here, I need 1% or higher. I want this area that I have shaded, the area above this unknown value, to be 1%. So that is 0.01 in decimal form. That's what I want. What value do I need to ensure that this area above is 1%? So I'm going to move over to my probability calculator, and it will tell me this. I'm going to select greater than because I am interested in the top 1%, I'm going to go over to my probability side, and I'm going to type in 1%. And then I move to the other box, and this is my answer. It's telling me that I'm going to need a z-score equal to 2.326. I'll just round it there. I need z to be 2.3.6 to achieve this goal. If z is equal to 2.326, then the probability that any given z-score is greater than 2.326 is about 1%. That is what I wanted. And then we say, all right, I know what my z-score is, so what I ultimately need is I need whatever my data value is minus the mean, 462, divided by the standard deviation, which is 119. I need that to be equal to this z-score, to 2.326. I need this to be true, that my data value minus my mean divided by standard deviation is this. I don't know what my data value is yet. That's what the question is asking. What observation do I need to ensure that my z-score is 2.326, which will ensure that the score is in the top 1%. So, like before, to finish this then, I just need to solve for x. So I'm going to start by multiplying both sides by 119. This is going to give me x minus 462 on one side, and on the other side, 2.326 times 119 turns out to be 276.794. And then I'm going to add the mean 462 to both sides, being careful to line up place values. So adding those two together, I end up getting 38.794, which rounded is approximately 739 points. So we say, all right, in this case, we found this, what this is telling us, this 739. This means that the point on the horizontal axis, to ensure that the area above that point is 0.01, that point needs to be 739 rounded. This is telling me that ultimately a person needs to score at least a 739 to be in the top 1%. Which is the requirement, or at least what was expected for this graduate school. So, to summarize, when you are trying to compute these types of problems, these are both inverse probability problems. Make note when you start with these questions, kind of ask yourself, what are you being told? Just to look at some examples from a previous video. If I'm asking something like, or if you're being asked something like, what is the probability that a randomly selected test taker earned something? Here it is asking for a probability. So you find the z-score and you use the probability calculator to compute the probability by entering in a z-score. If the question doesn't ask about a probability and instead it's asking about a variable, this is about scores on a standardized test, and the question is asking for a score on this standardized test. If it's asking for an x variable, then, and it's giving you a proportion or a probability, you use the equal sign, that's probably on the other side, the probability box, to calculate what the probability is going to be. That tells you the z-score you will need to achieve that probability, and then you can use the z-score formula to solve for the variable that you need. Note that it is possible to just formulaically solve this equation for x, and you are welcome to do that if you would like. The last thing to summarize is just to decide exactly, or be aware of which shading you need to do. That is the first step to figure out. And then after that, you just get to calculate. All right, I hope this was helpful.